Continuing with the application on power and effect sizes and testing hypothesis, here's another example that also you can find on Blackboard under the power definitions sections. Um, it says a researcher investigating the effect of triplypsam on GERD recruited volunteers with GERD and randomly allocate them to two groups. So one is receiving the treatment, the triplypsam, versus the other group which received the placebo. He concluded that the drug is effective. So that is his conclusion. And that's all what you're provided with. And then you have a list of questions. So the first question says, what test was used? Okay. Every time you're asked that question, you need to ask yourself the three questions. How many groups? Are they the same people in every group? And what is the outcome? So the first question we're asked how many groups. We have two groups. One group is the triplypsam, the other one is the placebo. The second question is, are they the same people? No. We're told that he randomly put them into these two groups. So these are not the same people. The last question to our question is, um, is the outcome numerical or is it categorical? And based on the information you have here, it's not clear if it's categorical or numerical. Amma, if we stuck with effective, and the answer is just so it's either going to be an independent t-test if the outcome is numerical. If the outcome is not numerical, is actually categorical, then it's going to be the Pearson Chi-Squared. And to help you answer that, I'm just going to go back to the last slide here, and that's where you have the two groups, okay? And the groups are independent. So if your outcome is numerical, you're going to use the independent t-test. But if your outcome is categorical, then you're going to use the Pearson Chi-Square. All right, so let's go back to the questions. What was the p-value? Well, his conclusion was that the drug is effective. Let's think about what the null hypothesis would be. Remember, the null hypothesis always declares no effect, no difference, no change, nothing is happening. Since he concluded that the drug is effective, he must have rejected the null hypothesis. And to reject the null hypothesis, his p-value has to be less than alpha. What was the statistical conclusion? That's question number 3. Since he actually concluded that there is an effect, then his statistical conclusion had to be that he rejected the null hypothesis. Okay, so what we know so far is that he got a small p-value less than alpha, he rejected the null hypothesis, and he concluded that the drug is effective. Question number 4. After the study ended, the researcher discovered that his research assistant was giving both groups the placebo. What does that say about the reality of the null? Yani in fact, he was not comparing two different groups, not the triplypsam and the placebo. He discovered he was comparing placebo to placebo. When you're comparing placebo to placebo, that means that there's no difference. And therefore, that means that in reality, there is no difference. And the hypothesis that declares that in reality there is no difference, that would be your null hypothesis. So according to that information right here, we can say that the null hypothesis is true. So follow up on number 4. What can we say about the research conclusion? How can we remedy that problem? Does the study require an IRB approval? So let's go back to our flipboard right here. So we were discussing a minute ago that if actually we were comparing the placebo to placebo, that would have mean that the null is true, okay? But we have said previously that the researcher has rejected the null hypothesis. So we have a condition, we have a situation where the researcher rejected the null hypothesis, but now we know that the null hypothesis is true, and therefore that means that his conclusion was a type 1 error. When you have a type 1 error, can you fix it by increasing your sample size and therefore increasing power? No, you cannot, because your null hypothesis is true. We cannot discuss power. Power is only discussed when your null hypothesis is false. So how do we remedy this problem? Well, he has to repeat his study. That's the only thing he can do. All right, so let's go back. What can we say about the research conclusion? It was a type 1 error. How can we remedy the problem? Well, no, you have to start from the beginning, and this time make sure that you're actually giving the drug to the patients and not placebo for both. Does the study requires an IRB? The answer is always yes. You need always to have an IRB to answer that question. Now, the follow-up is we are told that the degrees of freedom is 1, which test was used. You'll be able to answer that question once we cover the chi-square. And since if you haven't covered the chi-square so far, you will not be able to answer that question. So we're just not going to address that right now. Let's go back to the final example we have on Blackboard. It reads, a clinical study looked at a drug that is supposed to regulate insulin in the blood. To do they recruited, I don't know, there is a verb missing here, maybe like to do the study, to investigate, to do this. They recruited 400 diabetic patients, half of whom received the drug and half received the placebo. The difference in insulin after 2 weeks of treatment was 12 units favoring the drug. The research concluded that there is evidence that the drug regulates insulin. First question, what is the null hypothesis? Well, here we're comparing two groups, and we're interested in levels of insulin. So the null hypothesis has to be that mu of insulin in those receiving placebo after treatment is equal to mu of insulin in those receiving the drug after treatment. That's the null hypothesis. What is the independent variable and what is the dependent variable? Okay, so the dependent variable is your outcome. What is the outcome that you're measuring here? The outcome you're measuring here is insulin's level. So your dependent variable is insulin level. What is the independent variable? What is the independent variable is your exposure. What is impacting your insulin? And that is treatment. So whether they did or did not receive the treatment, that would be your independent variable. What was the test used? Again, this is where you're going to ask how many groups do I have? Same people, walala, and what is the outcome? And you have two groups, they're not the same people, so independent groups, your outcome is numerical, so that's going to be your independent t-test. What was the statistical conclusion? Well, if you go back and you read the last two sentences, the differences in insulin after 2 weeks of treatment was 12 units favoring the drug. The researcher concluded that there is evidence that the drug regulates. So obviously he rejected the null hypothesis and declared that the difference is statistically significant. And to be able to do so, what is the statistical conclusion? Reject the null hypothesis. What could be a possible p-value? Well, any value that is below 5% is a possible value. If the conclusion of the researcher was correct, what could be said about the reality of the null? So let's go back here. So we know that he rejected the null hypothesis. Since he rejected, either he made a type 1 error or it's power. Now we're told that his conclusion is correct, so it has to be power. So therefore, that means that the null hypothesis has to be false. Again, what is the null hypothesis? That there's no difference between the two groups. So, so if the conclusion is correct, what could be said about the reality of the null? The reality of the null is that the null is false. If a reviewer of the results revealed that there was an error in the calculation and the difference was actually 8 units, how did that impact the study? Okay, this is perfect. Because what we had a difference of 12 units, and now it turns out that the difference is actually 8 units. Now, where do we fit these 8 units or 12 units? Remember in our discussions, between all of this, we linked 3 things to each other. We linked power, we linked sample size, and we linked effect size. Excuse me if it's not very clear. And that 12 actually was the effect size, and it turned out to be actually smaller. So it turns out that it's 8. So here we have a scenario where the effect size was mistaken to be 12 and turned out to be smaller. How is that going to impact anything? Well, it's not going to impact sample size. Your sample size is constant. It didn't change. We didn't go and recruit more people. But what it's going to do, it's actually going to impact your power. So whatever your power that you had initially, it's going to be reduced to a lower power. So the answer to that question is that how it will impact the study. It will impact it by having less power. شو معناتها you have less power? It means that maybe now you can no longer reject your null hypothesis. Maybe now you're going to find yourself in a situation where you're going to fail to reject your null hypothesis. Okay, I guess this is the example, and I hope you enjoyed them.